faithfully delivering value by interpreting the world's best books. Um, Hi, this is Sally talking books. Today, I'm going to interpret this book titled Dinosaur Secrets for you. Most people's impressions of dinosaurs come from sci-fi movies like Jurassic Park, Jurassic World, and so on, or from dinosaur fossils in natural history museums. And what impresses us are the fierce and brutal Tyrannosaurus Rex, the long-necked Brachiosaurus, and the Triceratops with its big head like a rhino, and so on. In the movies, they come to life vividly as if they were living alongside humans. In fact, dinosaurs went extinct 65 million years ago, while humans only emerged a mere few million years ago. Humans and dinosaurs never coexisted. The scenes of humans and dinosaurs together in movies are purely science fiction. So, how did humans come to know about dinosaurs? Actually, all human imagination about dinosaurs is based on the discovery of dinosaur fossils. Scientists study dinosaur fossils and other prehistoric remains using archaeological methods, striving to reconstruct the true appearance and life scenes of dinosaurs for people. The author of this book, David Norman, is the curator of the Earth Sciences Museum at the University of Cambridge and an expert in vertebrate paleontology who has long been dedicated to research in paleontology, anatomy, and evolutionary science. This book, Dinosaur Secrets, is based on dinosaur archaeological discoveries over the past 2 centuries, introducing us to the latest advances in dinosaur research, speculating on the prehistoric dinosaur world, and restoring the life and times of Earth's prehistoric rulers. Next, I'll use 3 questions to explain the content of this book for you. First, how were dinosaurs discovered and named? Second, how do people understand dinosaurs through their fossils? Third, what is the life and history of dinosaurs? All right, let's start with the first question. How were dinosaurs discovered and named? In fact, humans discovered dinosaur fossils very early on. It's said that in ancient China, in the Sichuan-Zhejiang region, dinosaur fossils were unearthed. However, people back then didn't know what these fossils were and mistook them for the bones of dragons from myths and legends. In the myths of ancient Greek Mycenaean civilization, there's a mythical beast called the griffin, which has an eagle-like, sharp beak and claws, and a lion-like strong body with a long tail. Scientists believe its prototype is the Protoceratops fossils from Central Asia. Nomadic tribes in Central Asia likely discovered complete Protoceratops fossils in the desert and imagined the griffin, then brought its legend to Europe via the ancient Silk Road. It wasn't until the 19th century, with advances in geology, that dinosaurs truly moved from myth to science. Back then, European scientists found fossils of an unknown ancient reptile across Europe. They were often massive and unlike any animal today. But these fossils are in strata dating from 250 million to 65 million years ago. British anatomist Richard Owen officially named these creatures dinosaurs in 1942. Actually, the standard Latin name for dinosaurs is dinosaur, meaning terrible lizard. Owen named them that because from the fossils, these ancient creatures appeared huge and terrifying. Like lizards, they had sturdy limbs for crawling, triangular heads, tooth-filled mouths, and long tails. In China, scientists used the familiar concept of dragon to translate this ancient creature as Kong Long, meaning dinosaur. In 1851, London hosted the first World's Fair. After the fair ended, the exhibition building, the Crystal Palace, was moved to the suburbs and turned into a science-themed park. In this theme park, the most eye-catching exhibit was the first ever reconstructed dinosaur model. The builders cleverly hosted a celebratory dinner inside the belly of a dinosaur model. Later, after media hype, dinosaurs became famous. Subsequently, dinosaur models were displayed in science theme parks and museums worldwide, gradually becoming accepted and well known by the public. However, the dinosaurs Owen discovered and named back then were only three types: Iguanodon, Megalosaurus, and Hylaeosaurus. Then, in the last 3 decades of the 19th century, the focus of dinosaur research shifted from Europe to America. Two famous American paleontologists, Edward Cope and Othniel Marsh, discovered over 140 new dinosaur fossils, greatly enriching the dinosaur family. Today, dinosaur fossils have been found worldwide, including Antarctica, with over 350 species discovered. The first scientist to find a new species can name it. Naming is often based on some characteristics of dinosaur fossils. For example, Megalosaurus got its name because this type of dinosaur had huge teeth, and Deinonychus was named for their terrifying claws. Compsognathus was named for their beautiful jawbones. Pachycephalosaurus was named because their heads have bump-like protrusions, which is quite interesting. Then there's Oviraptor. They were called Oviraptor because when scientists first found their fossils, their death posture looked like they were stealing eggs. But later, more Oviraptor fossils were excavated, proving they weren't stealing eggs but protecting their own. However, the name Oviraptor has stuck in people's minds, so it wasn't changed. All right, so we've covered the first question of this book, how dinosaurs were discovered and named. Actually, all this is based on the discovery of dinosaur fossils. So, how do archaeologists and paleontologists understand dinosaurs through their fossils? This is the second question we'll discuss today. Like other organisms, after most dinosaurs died, their bodies were quickly decomposed by microbes in the air, leaving no remains. Only if they were quickly buried by thick sediments like mud, sand, or volcanic ash, their bones fossilized to become dinosaur fossils. Scientists estimate that on average, only 1 in a million dinosaurs might become a fossil and survive to this day. Today, most unearthed dinosaur fossils come from bodies buried by natural disasters, like floods, mudslides, or volcanic eruptions. The remains were buried underground, fossilized over tens to hundreds of millions of years, with several crustal changes. When fossils are unearthed, they're usually incomplete. Dinosaur bone fossils are scattered chaotically in the strata, like building blocks. Many dinosaur models we see today are inferred and imagined by scientists through piecing together fossils. However, piecing fossils together isn't easy. It's like building blocks with many possibilities, and many fragments are lost during geological changes or damaged during excavation. Therefore, the models scientists build for the same dinosaur species can vary greatly, especially in early excavations when scientists had fewer fossil fragments. They added much subjective imagination to reconstruct dinosaur appearances. These differ greatly from models we see today. For example, the Iguanodon model first reconstructed by Owen, the namer of dinosaurs, had an elephant-like body with sturdy limbs, a crocodile-like head with almost no neck, and a tail resembling a thick log. But with more fossil discoveries and advanced techniques like CT scanning, today's Iguanodon model is completely different. Though similar in size to elephants, modern iguanodons have much more developed hind limbs than forelimbs. They could walk upright with ostrich-like heads and flexible long necks, and their tails weren't log-like but tapered cone-shaped. When walking upright, the tail acted like a third leg, helping maintain balance. Moreover, their thumb spikes were dagger-sharp, used for fighting other dinosaurs or cutting food. Beyond bones, other dinosaur traces can also fossilize, like footprints, hair, skin, muscles, blood vessels, soft tissues, even internal organs, though extremely rare. Such discoveries are exceptionally uncommon. For instance, in the 1990s, a dinosaur fossil was found in South Dakota, USA. Inside its skeleton was a large iron-rich nodule. Scans revealed two chambers and structures resembling aorta and vena cava. Scientists concluded this was likely a fossilized heart formed through mineralization over millions of years. Preserving heart tissue for tens of millions of years is extraordinary. To date, scientists have reconstructed over 350 dinosaur species and classified them. Based on physiology, dinosaurs are divided into Saurischia and Ornithischia, primarily distinguished by hip structure. Saurischian hips resemble lizards with forward-projecting pubis bones. Ornithischian dinosaurs have hip structures similar to birds with backward-projecting pubis bones. Saurischian dinosaurs, however, are very diverse and include two suborders, Sauropodomorpha and Theropoda. Sauropodomorphs are mainly large herbivores like Diplodocus, Brachiosaurus, and Brontosaurus, reaching lengths of tens of meters. Theropods are typically fierce carnivores, such as the well-known Tyrannosaurus Rex, Baryonyx, and Spinosaurus. In contrast, ornithischian dinosaurs are generally much smaller and cuter. Most are herbivores, somewhat like modern antelopes, goats, or deer, making them the primary prey for carnivorous dinosaurs. For example, the iguanodon, Pachycephalosaurus, and ceratopsians mentioned earlier all belong to this category of dinosaurs. However, whether Saurischian or Ornithischian, all dinosaurs share some common traits. They are terrestrial egg-laying animals that reproduce by laying eggs, similar to birds. Hearing this, someone might ask, were all dinosaurs terrestrial animals? We clearly see flying pterosaurs and swimming plesiosaurs and mosasaurs in sci-fi movies. Indeed, these prehistoric animals lived at the same time as dinosaurs and are also called dragons. So many people mistakenly think they are dinosaurs, but they are not. They are just close relatives. All dinosaurs, like humans, lived on land. All right, we've covered that. For the second question, people study dinosaurs through fossils and classify them into two main groups based on hip structure, Saurischia and Ornithischia. So, where did dinosaurs come from? And where did they go in the end? In other words, what is the life story of dinosaurs? This is the last question we'll discuss today. According to Darwin's theory of evolution, all species on Earth have undergone long evolutionary processes, and dinosaurs are no exception. Dinosaurs first appeared 225 million years ago and went extinct 65 million years ago due to a natural disaster, existing for 160 million years on Earth. Compared to dinosaurs, humans have only evolved over a few million years, showing that dinosaur evolution was much longer and more complex. So where exactly did dinosaurs come from? Scientific research proves that all life on Earth originated in the ocean. About 400 million years ago, fish gradually evolved into amphibians and reptiles that came ashore. Scientists speculate dinosaurs likely originated from reptiles. And speaking of reptiles, they're an ancient species. Familiar animals like lizards, crocodiles, snakes, and turtles all belong to reptiles. Scientists discovered a reptile fossil in strata dating back about 230 million years, the Lagerpedon fossil. Lagerpedon was rabbit-sized but had longer legs and neck than crocodiles, showing dinosaur-like features. Thus, Lagerpedon is considered an intermediate species, evolving from reptiles to dinosaurs, proving dinosaur origins. The earliest known dinosaurs are Eoraptor and Herasaurus, living about 225 million years ago. This period was the early Mesozoic era, called the Triassic period. The Mesozoic chronologically divides into Triassic, Jurassic, and Cretaceous periods. If Triassic was dinosaur origins, Jurassic and Cretaceous were their golden age. During these periods, dinosaurs diversified enormously. Giants like Seismosaurus reached 30-plus meters, while tiny Compsognathus was mere centimeters. Adapting to environments, some became fierce carnivores, others gentle herbivores, and some omnivores like humans. Not just appearances changed, their bodily functions also evolved. Early dinosaurs were cold-blooded ectotherms like reptiles. They relied on external heat sources like modern turtles or crocodiles basking for energy. Early dinosaurs were the same. Scientists speculate some dinosaurs' backplates, like Stegosaurus's blade-like structures, acted like solar panels absorbing sun energy to sustain them. But through evolution, dinosaurs transitioned from cold-blooded ectotherms to warm-blood endotherms, maintaining body heat through digestion rather than external sources. To maintain body heat, some small Saurischian dinosaurs like Deinonychus and Microraptor evolved feathers to prevent heat loss. By the late Cretaceous, many small Saurischians, including Deinonychus and Microraptor, evolved wing-like forelimbs to catch flying insects. In strata from this period, Archaeopteryx fossils found in Europe and Sinosauropteryx fossils in China represent the most primitive birds. Research shows Archaeopteryx resembled Deinonychus, while Sinosauropteryx resembled Microraptor, indicating they were transitional species from dinosaurs to birds. Thus, dinosaurs are birds' true ancestors. About 65 million years ago, a massive catastrophe, likely an asteroid impact, caused all dinosaurs to go extinct. But smaller dinosaurs' descendants, birds, survived tenaciously and thrive today. Here we conclude the book's third question. What is the life story of dinosaurs? Scientists infer dinosaurs likely evolved from reptiles, gradually transitioning from cold-blooded to warm-blooded. 65 million years ago, dinosaurs tragically went extinct due to a natural disaster, but a small portion evolved into birds that live today. Today, with technological advances, many imagine resurrecting dinosaurs through genetics to bring this amazing species back. Indeed, some genetic fragments persist in fossil remains, especially soft tissues, but after millions of years they're fragmented and contaminated. Current tech can't extract complete DNA, making resurrection sci-fi for now. Perhaps future science could clone a real dinosaur, but Earth lacks space to restore the thriving dinosaur era. And ancient Earth's rulers still hold secrets quietly waiting in strata for exploration. Right, that concludes Dinosaur Secrets. Reading notes are below the audio. See you in the next great book.